Ever wondered why magnets stick to your fridge but not to your wooden table? It's a curious phenomenon that many of us take for granted. Magnets seem almost magical in their ability to attract certain materials while ignoring others. But there's a fascinating science behind this everyday occurrence. It all comes down to the fascinating world of magnetism. Magnetism is a force of nature that has intrigued scientists and curious minds for centuries. From ancient lodestones to modern electromagnets, the study of magnetic forces has led to incredible technological advancements. To understand magnetism, we need to dive deep into the heart of matter, the atom. Atoms are the building blocks of everything around us, and their internal structure holds the key to magnetic properties. Atoms are made up of protons, neutrons, and electrons. Protons and neutrons form the nucleus at the center of the atom, while electrons orbit around this nucleus in various energy levels. Electrons, the tiny particles whizzing around the nucleus, are key to magnetism. These electrons are not just passive particles, they have intrinsic properties that contribute to the magnetic behavior of materials. Electrons have a property called spin, which is like a tiny internal rotation. This spin creates a magnetic moment, making each electron a tiny magnet. This internal rotation, or spin, is fundamental to the magnetic properties of materials. When many electrons in a material have their spins aligned in the same direction, the material itself becomes magnetic. In most materials, the spins of electrons are randomly oriented, canceling each other out. This is why most materials do not exhibit noticeable magnetic properties. But in magnetic materials like iron, nickel, and cobalt, something special happens. The electron spins in these materials can align in the same direction, creating a net magnetic effect. The electron spins of many atoms align in the same direction, creating tiny magnetic regions called domains. These domains are like small magnets within the material. When these domains align in the same direction, their magnetic fields combine, creating a larger magnetic field that we can feel. This alignment is what gives a magnet its strength. Their magnetic fields combine, creating a larger magnetic field that we can feel. This is how a magnet gets its properties. The strength of a magnet depends on the degree of alignment of these domains. This is how a magnet gets its properties. Magnets can be permanent or temporary, depending on how the domains are aligned and whether they stay aligned over time. There are different types of magnets, each with unique shapes and strengths. Bar magnets, horseshoe magnets, and electromagnets are some common examples. Each type of magnet has its own specific uses and advantages. And electromagnets are some common examples. Electromagnets, for instance, can be turned on and off with electricity, making them incredibly versatile for various applications. Magnets have numerous applications in our daily lives. From holding notes on the fridge to powering complex machinery,